engineering in electrical and electronics engineering from the University College of London. He also has many cloud-related and DevOps certifications. In his free time, Peter enjoys orienteering and learning about new technologies such as artificial intelligence. He is also one who is always keen to help others and give back as often as he can. So he engages in charitable and philanthropic endeavors as much as he can, especially in Africa. Peter is a firm believer in the Thomas Edison quote that genius is 1% perspiration and 99% genius is 1% inspiration and 99% perspiration. And using that as motivation, he is determined to continue to improve on his technical and personal skills. He also would like to increase his philanthropic activities in Africa, and he hopes that this will, go a long way in helping to save the planet. So join me to welcome Peter. It is very good to have Peter here with us. Over to you, Peter.
Thank you very much, Mercy. Whenever I'm introduced, I usually don't know it's me they're talking about most times, but it's me. Thank you very much for being so kind. So I'm here to talk to you today about DevOps, but I just give you a bit of background about myself, just to add a bit more. So I am the CIO and partner at a company called Puro Labs, and we specialize in big data, data ops, which includes DevOps and also data operations, and then analytics. All this is what we use to power our business intelligence service. And on top of all this, we are very, very strong believers in cloud computing. So we have what you call a very cloud-centric approach. We don't do anything without saying, what's the cloud? How can the cloud help here? And what can we do to, utilize and enhance our clients, productivity, efficiency, and also, data investigations using the cloud. So that's it in a nutshell. Like I said, we're a very cloud-centric approach. We deal with all kinds of cloud technologies. We're a Microsoft partner, currently working towards getting our AWS partner certification going. And we do all kinds of things from and analytics side, from down to the low-level resources and to the delivery side on the client side, maybe doing reporting or maybe helping with ETL. Now, what are we talking about today? So I'm here today to talk to you about DevOps, what it is, introduce the concept to you. If you already know what it is, awesome, that is great. You can also chime in. You can also, let me know what what DevOps means to you. To me, if you start from the fundamentals, like there's been a history of how DevOps and most things in technology, there's always been a lineage to how we got where we are today. If you look at DevOps, DevOps started from a place where, sorry, I don't know, is that better? Oh, okay. DevOps started from a place where we were, if you're old enough to remember, back in those days when we used to go into our data centers and we needed to make changes to our operations or to our infrastructure or even to deploy code. You would need to fill in some paperwork. You would need to speak to maybe a compliance manager, a project manager, or even the product owner. And, okay, we'll get the infrastructure changed. Now, the next step is to now engage with the, and we could have done this before, but engage with the developers. What do you need? Do you need 5 processors? Do you need this much RAM? What versions of this, library do you need? And all those things. So if you look at everything I just said, in fact, it's a mouthful. It can take almost, I don't know, weeks to get all these things ironed out. And then you get to the point where we're doing delivery. We're about to deploy the code that the developers have spent many, many months writing, testing locally. Now we want to deploy it into, say, a development environment. That would take another X number of weeks because one, they would deploy it, they will find issues, go back to the drawing board, fix it, find issues. And so while that might seem efficient, it is not, because that whole every time the iteration just keeps adding and adding and adding. Of course, the product owner, who's the person sponsoring the project, right? Or who's, the guy, one of the stakeholders in the project, has his own or her own expected delivery dates. They want to, for example, in a bank, make money off a feature that they've asked for. And it's now taking, a long time. And what you usually find is that there's always either scope creep, time velocity is gone, reduces, and then it takes a long time to finally get this feature out. We've tested it now in dev. Now let's deploy it into production. When you finally deploy it into production, you will get more errors, or you could hit more brick walls, because the version in dev, one library there was not correct. Somebody had gone in there into production, manually updated the library, and done all this stuff. So the fundamental problem there was that the development environment was not the same version as the production environment. I'm talking about a fraction of the issues that used to occur in the past. There's a great book I'll recommend to you towards the end of this session if you're interested in how the history of DevOps and a classic example of how DevOps has helped many organizations and what it is and where it's going. But that's all in the past, right? Everything I've told you is how we used to do things in the past. In the last couple of years, we now have entered a new paradigm called DevOps, entered the fray, where we're much more conscious. Everyone, if there's a product that needs to be developed, we're more conscious that the product needs to be divided into what you call features. We need to be able to deliver quickly, efficiently, and in a way that we get feedback constantly from all our deliveries. So you imagine you're trying to, in the past, deploy a piece of software to the bank that updated an ATM. Now in the past, it goes through the same cycle I talked about. But now the whole process is now streamlined, where instead of delivering a big, what we call, we could call it, a fat client. But now we're delivering small changes incrementally. So these changes, we usually can call them features, or they can be as small as a feature, or they can even be smaller than that. Call them a task if you live in the GitHub world, or you can call them a story. Depends on what you want to call it. But the whole concept now is that the whole idea is that we now deploy changes incrementally. And that's where this whole concept of CI/CD comes in. We have small change. Instead of us waiting a whole week or 2 weeks, 3 weeks to deploy a change, we make the change locally on our laptops, virtual machines, and then we commit the change into a central repository. The central repository has what you call an automated policy, which on commit, for example, will now deploy the code to build the code into a package, test the code. So if you look at the diagram here on the screen, it will start by, let's say, writing the code. Then writing a small piece of code. Bear in mind, I'm talking about a small piece of code here. You commit the code into a repository. We have agents that will build the commit, build the code. That code will be a package will be created. And also while the build is going on, you also have what you call unit tests running. You have all kinds of tests, but they're unit tests, they're cross kind of tests, testing at that stage. And then we release the change into a development environment. Once we released it, we're happy with it, we can then even automatically deploy it into a production environment. We get more feedback. So now we monitor what we've released, and automatically we get that information, which we call feedback, and then we continue iterating. So this is why this diagram, it looks like an infinity symbol, because the whole idea of DevOps in a nutshell is that we're consistently and continuously integrating, that's what we call CI, and then continuously deploy or delivery, depends on how you look at it, into the environment to capture information. Now, the reason why this is very important is because now we don't have to wait anymore for feedback. We don't have to, if dev is a different version behind fraud, we would know quickly. Teams can be worked much more efficiently. Now, that's another important element of DevOps, is that now you can have teams that are built around a specific product. Historically, what used to happen is that you would have maybe a server team or a Linux administration team or Unix administration team, a database administration team, network security team, all sorts of teams, and to follow an infrastructure stack. But with the concept of DevOps now, you can now build a team around the product. So you can now say, well, I just need a networks engineer, I need a database admin, and I need a Linux admin. I'm going to add them to this small team I am creating. I need 2 developers. I'm going to add them there, a business analyst, a project manager, and that is it. These guys will be put together to solve a specific problem. And that is how DevOps has helped us to be able to make things easier. So this course is about introducing you to DevOps. First, you start with the introduction, get an understanding of what DevOps is, how it's implemented in different organizations, how the proposal, what we're proposing from a DevOps point of view. And then you move on to the different things that have enabled DevOps to be very successful, like containers. DevOps is, when people say DevOps, it's sometimes it can be loosely used to refer to everything that encompasses the modern day technology environment, which includes like serverless, containers, and other things. So we're continuing with that light because I truly believe, as a DevOps engineer, you should really understand how to create containers, use repositories like GitHub, Azure, Git, DevOps. You should be able to automate and create pipelines. So all those things are there. You should also understand the concept of, yes, you can create containers, but how to run containers. We're not talking about running on servers here. We're talking about running containers in Kubernetes. So this course focuses on Kubernetes. There are other platforms out there that support containers, but we're focused on Kubernetes. Then when you learn about that, you also need to understand that DevOps is not just about developers. Like I said, the team could be made up of infrastructure engineers too. So infrastructure engineers need to be able to understand how to deploy code infrastructure into the environment. So we will talk about things like Terraform, Ansible, and also configuration management tools. Oh, that's literally what that whole section. So there's a section there for infrastructure management using configuration tool management tools, like I mentioned, Terraform, Ansible, and I think there's one more there. Then once you go past that, now, you have all this knowledge. There are many ways you can deploy these things. You can either get a computer, in your house and deploy them, or go to a data center, which, like I said, that's legacy tech to me, unless if you're specialized data, but from a DevOps perspective, you're talking about the cloud. So now you're talking about how you can deploy your infrastructure and your code into the cloud. So there's a track where we would talk about what the cloud is, cloud technology. It's very agnostic. And what that means is that it's not focusing on just one specific cloud type. We're just talking about what the cloud is. So if you don't know what it is, I think it's a good place to also join into. You learn about the cloud, and then you would also learn about the different cloud vendors that are out there right now. Off the top of my head, you have GCP by Google, you have AWS by Amazon, you have Azure by Microsoft, and there are quite a few. IBM have theirs too. There's OpenShift by Red Hat, and there's Alibaba and all those guys. But the 3 popular ones, we would focus on just 3 of them. So GCP, AWS, and Azure. So that is how the course will play out. It's an intermediate to, the standard protocol. It starts with introduction, and then we progress through the course to empower you with hands-on experience towards the end of the course. But I kid you not, it's a very exciting, I'm pretty excited to be part of this, course. And with that, I pass over to Christian for any questions. Thank you.
Okay, thank you very much, Mr. Peter. That was an exciting presentation on DevOps course. I know most of us will have questions. You can just ask your questions in the chat. If you want to know more about the course, like I said, this is an introduction into the course. You want to know how it relates to you being a data scientist or a data analyst or a machine learning engineer, you can just drop your questions in the chat and I'll read it to Mr. Peter. Okay, we have a question here from Chukwuebuka. It says, what's the benefit of this DevOps to data scientists?
It's a very good question. I don't want to feel like I choose one over the other, because I think they both complement each other. Because as a data scientist, it is very important to have some DevOps understanding. You probably already use DevOps or some tool sets that forms part of DevOps. If you use a source control repository, you're already on your way there. You use Python to automate your things, you're already on your way there. You understand all these concepts. So what we're teaching here is we're pulling everything together so that you can now also understand things like the cloud is also very important. Containers. If you're a data engineer, you're using maybe Kubeflow, for example, you're using all these kind of nice tools already to deploy your AI. Now you can use, if you understand how you can deploy not just Kubeflow to a GCP platform. If you understand Kubernetes, for example, you can push to other environments. You can also learn about how to package your tools. So I think it's for everyone. They complement each other. I am biased. If you ask me without me being biased, I said what I've said, but I am biased because I'm a DevOps engineer. I actually started out as a database administrator many years ago, but the future is cloud computing. The future is understanding automation and DevOps. You see, in fact, in a few months, there's already site reliability engineering, which is another, is another version of DevOps. Some people don't like it, but it's a fast-moving environment. So just grab the skills that you can now, is what I'll say, and they complement each other.
Okay, thank you very much for that answer. There's another question. It says, can a software development newbie get straight into DevOps? As a beginner, can you get straight into DevOps?
Yes, absolutely. Because the course itself, you can get to DevOps generally. You have to start from somewhere. With anything in life, you have to start from somewhere, right? So this course was designed to help people that don't have DevOps background. It's really nice to have a technical background, or you want to just learn something, but you would have to put in a lot of effort too. Don't get me wrong. The course is not just here to just drop everything to your mind. You have to go and do the coursework. You also have to do some background reading. If there's recommended reading material, go and read it, because it's supposed to be a very streamlined course, but you need to put in a lot of effort. So yes, you can. It's my answer, but be prepared to work hard for it too.
Okay, thank you very much. And there's another one from David. It says, what are the skills required of a DevOps engineer? That's the skills.
Just like an interview. So as a DevOps engineer, the skills you need to have, I think with most things are the soft skills. You need to have some soft skills, like a bit of patience, communication. You need to be able to know how to formulate, when you're talking to people, you need to be able to talk in a way that is objective, not subjective, because one thing that you will find is that if you're familiar with the way Agile methodology works, the concept of Scrum, the concept of stand-ups, where people will sit face to face with you and ask you, what did you do? Why is this thing your work or not working? You need to be able to understand that you're asking from the concept perspective of the success of the project. So being able to communicate, patience, and being very, focused on what you're doing. And what I mean by that, it means that if you're really given a task to do something, be ready to go and expand your mind, be ready to learn and work hard, because being a DevOps engineer requires a lot of, I'll say extracurricular powers, because you need to be able to, if somebody says there's a problem, you're not going to be the person that will sit down and say, okay, let somebody else solve it. You probably have to get ready to go and look for solutions and propose it to the team. If they say, no, it's not a good solution, it's not a problem. If you argue your case and it's not a problem, don't feel bad about it. So that's soft skills wise. Yes, that's what you need. Technical skills wise, from a technical perspective, again, it helps if you have some background in IT, any IT background. But if you don't, be prepared to learn. Like the course starts easy, in the sense that we're not introducing any technical abilities, but it's a good idea to have a concept of programming languages. You don't need to know any specific ones. We'll just know what a class is, a function, a variable, things like that.
Okay, thank you very much. Like this question is like similar. I say, what is essential to learn to become a successful DevOps engineer? That's the essential skills to learn to become a successful DevOps engineer.
Okay, and maybe I'll just build on the last question. When I say essential skills, yeah, okay, so I would maybe say if you really want to be successful as a DevOps engineer, learn about infrastructure as code, learn about the different release patterns, strategies, which we also talk about in this course. Learn about, have a programming language under your belt. The common thing these days is Python. There's also Go. Go is nice, amazing. There's Python, there's C#, there's anything you want, even SQL, have that under your belt, but have good understanding of programming and have under your belt. You know, then also, like I said, just, you know, talk to people, be engaging, attend seminars, you know, and learn, just learn, get your hands dirty, you know, those are the essential skills you have to learn. I can also provide a list after the meeting if you want because I'm sure there's a list somewhere on the internet about this that says it better than what I've just said, but I'm happy to dig one out.
Yeah, exactly. Thank you very much. There's a question here. It says, okay. Paul is asking a question. He said an integral part of our power system network. He's asking how is that possible? How can that be done? How can DevOps be an integral part of the power system network?
Yes,
It's a great question. So I'll take a few steps back. Like I think last year we had a talk here about how demand forecasting. So demand forecasting is how you can forecast demand, how you can, you know, if you're in a power network, how can you foresee what will happen tomorrow based on temperature, based on historical data sets and things like that. If you look at that, you're introducing the concept of DevOps to your environment if you want to start forecasting demand, for example. Now, I know you're going to say, you know, that's not, but if you have a good understanding from a business perspective, you'll be able to quickly build a piece of infrastructure, even though it's just a small server in the cloud, that you can write some programs to that can ingest data, historical data sets, and then you can use that same program to now crunch. You can use an algorithm to crunch the data and predict. You've saved a lot of money for your power plant there, because if you're able to successfully predict using historical weather, historical geospatial data, and all these things, you can now tell you about tomorrow, we're going to expect potentially probability of high demand for this state or this country or wherever it is going to be high. Let us start getting people to work overtime. Let us start opening up, spinning up more turbines. Let us start doing more of these things. So from a reporting perspective and from a forecasting perspective, you can combine DevOps and a bit of data engineering to help your power plant. You can also use DevOps to modernize your power plant. You know, if your power plant has places where, this is a classic one, you have many different components that make a power plant, but are you able to monitor each one of them? So you can use DevOps to build a platform that allows you to also collect metrics. You can go and install monitoring equipment in all across your power network and capture all these data sets to now also do things like fault analysis. You can find out when things are going to spoil or going to get damaged. You know, the classic one for people in, you know, where people are consuming more electricity but not paying enough for. You can use DevOps to find all this stuff because you can see how much your outflow is going there historically and how much income is being generated. So you can use it for many different things, for monitoring, fault analysis, and also, you know, to predict.
Yeah, that's true. That's true. Thank you very much for that elaborate answer. There's another one from Chukwu Ebuka. He says, how is DevOps different from Agile and Sdlc? If there is a difference in it.
Okay, so like I said, SDLC, I think Software Development Lifecycle. This is an acronym that has been around for many years. It's been there. In fact, it's one of the earlier days of incarnations of, I won't say DevOps, but that is how things were done historically. And it's still done that way. Software development lifecycle is where you have a lifecycle where you will now say, well, we'll start with this. Well, let's gather requirements. Let's do this. We follow a life cycle where we're developing this software. So DevOps actually incorporates Sdlc into its track, because when you're using DevOps, you still can use the SDLC. You can still use Sdlc. From a developer's perspective, you can have your micro Sdlc lifecycle before you push your commit. Even from a macro perspective, DevOps still uses Sdlc because we still follow a process. It's just that we've turbocharged that process. I can't remember what the second thing there, but I think it was Sdlc and Agile. Agile is actually part of DevOps, to be honest. Agile is used in DevOps. Let me just say that way. So Agile is a methodology that, it's like if you consider the concept of Scrum, sprints, and all these things. So Agile is actually used in DevOps. So I won't say they're different. All these things are actually connected, but Agile is actually it's a foundational principle of DevOps.
Okay, thank you. Thank you very much. Kafayat has a question. She's saying, are they entry-level positions? Because it seems you have to be experienced from your description. She's saying there are entry-level positions for DevOps engineer.
Yeah, there are many entry-level positions because these days you need people who will be able to just work on specific, if you remember, we talked about the concept of teams. You need junior people in the team, you need senior people in the team. Not all features are complicated. Not all products are complicated. So there are entry-level positions. However, I'm very keen to understand what her concept is of entry-level, because entry-level could mean many things to different people. So are you talking about somebody with 1 year's experience, somebody with 2 years experience, 3 years experience,
Okay. I get that. There's another question from Moyo. He's asking, how does Gulang language really relate to DevOps and also Docker? The relation between the Gulang language, DevOps, and Docker.
So Golang is a language that that originated from Google, right? So it's used in DevOps. So DevOps is a concept, or some people say it's a life form, it's a process where you can use anything you want to in DevOps. Golang is just another language that can be used to enhance DevOps. It can be used to orchestrate. If you're maybe deploying some, I'll say Terraform infrastructure. So Terraform is what we use, is a configuration language that we use to deploy infrastructure into the cloud or into wherever you want to do it. Terraform, that's actual language. So the configuration language behind the scenes, the libraries are written by Go, the Go language, right? So Go is just part of, you can use Go to do anything you want in DevOps. So I'll say it's connected that way. In terms of Docker, again, Docker is a container orchestration, tool. Go, now you can use Go to automate your Docker deployments. You can use Go to embed Go language or processes in the Docker container. So you can have a serverless process that was written in a Go language, and you can have it deployed into a Docker container. So Go is very powerful. If you understand Go and know Go, that's amazing, because not a lot of people know Go, but it's very powerful because I think it's simplicity, and it's becoming quite popular, to be honest. So Go is good. It's a good language, but they complement each other.
Okay. Thank you very much for that. And there's another question. Is there a difference between MLOps, that's machine learning operations, and DevOps?
So you can tell. So machine learning operations. So MLOps is very similar actually, but MLOps focuses more on machine learning operation and machine learning, right? I won't say operational, but machine learning. The reason I say that is because while they are similar, DevOps, you're more talking about how you can deploy, tune, update, calibrate, and specific or I say generic components to your infrastructure. MLOps is focused more how you can deploy, tune, specific machine learning components. So you could talk about fine-tuning and creating an environment just for machine learning. deploying to that environment, orchestrating the environment and things like that. So ML ops, there's a whole concept behind it. DevOps, there's a whole concept behind it, but it's a synergy. There's a lot of synergy there, is what I would say. It's just that ML ops is very specific to machine learning operations. And you don't probably need to learn as much in ML ops. To be honest, everybody has a role to play in ML ops, but you'll find that within ML ops, you still have data engineering. You still have people that need to know DevOps. You still have people that need to, be able to spin up infrastructure.
Okay. Thank you very much. There's this last question. Person's asking, does DevOps need you to learn multiple stacks? If you are going into DevOps, you need to learn multiple stacks, programming language.
That's a very interesting one. I was reading the other day, I think it was on Reddit or Stack Overflow somewhere, where people were complaining about full stack developers and this one and that. To be honest, you don't need to learn multiple stacks because DevOps brings together the concept of a team. In a DevOps team, you have people with different skill sets. So you don't have to know everything. That's the thing. Like, you just have to know what you need to do to contribute to that team. So you could be just an infrastructure engineer, or you could be a database administrator, or you could be a data engineer. The whole idea is that we have a product to deliver and everybody brings to the team. It's nice to have multiple stacks under your belt because these days, in the long run, when you become a senior DevOps engineer or senior DevOps specialist, you will actually, you'd understand multiple stacks. You'd understand multiple languages, so that comes naturally. But don't get too hard on yourself saying that, no, you don't need all this now, because it's a team concept, right? With DevOps, you bring something to the team, but you will learn as you go ahead. So that's what I would say.
Okay. Thank you very much, Mr. Peter. This was quite an interesting session. The elaborate answers you gave to the questions, really do appreciate. There's no further questions for now. I guess everybody understands what he's been saying from the beginning. Like he said, because this is just introduction to DevOps. Yes, exactly. So if you're interested, you can just choose the track. Like I said, there's benefits to data scientists, or even if you're a software developer, DevOps is an interesting track to focus on. Thank you very much, Mr. Peter. Thank you so much.
Thank you very much.
I'll be handing over to Mercy for closing remarks.
All right. That was really awesome from Peter. And we all had a swell time. I was almost convinced to actually go do DevOps myself. Yeah. So if you are so sure, I think he spoke very convincingly about it. And it is something to actually have under your belt, even if you want to just major in another aspect, say data storytelling, engineering, or data science. So he spoke about how that you can grab all the skills that you can grab now, that you just grab it now while it is still quite, new to the market. So I think that looking at everything he said, if you have made a decision to, when the forms are out to choose your tracks, just choose DevOps. Okay, no other question is here. And Peter has recommended some books. Look in the chat. We are going to make these available to anyone who needs it, to know the books that he recommended for whoever is interested in the DevOps option. He spoke about the Phoenix project, the Unicorn project, and he said in the chat that the Unicorn project is the first book in the series. Oh,
I just corrected that. It's the second one.
Yeah, it's the second book in the series. So I'm guessing that they are sequels to the other. The Unicorn project is like the sequel to the Phoenix project. So if you want to get more, you want to know more about DevOps, so go read up all of these books. And that would be all for today. We hope you enjoyed this information session. Hope it was enlightening. It was actually enlightening. So we wish you all the best. And we are really grateful to you, Peter, for coming around and enlightening us about DevOps. Thank you very much. And if there are no further questions, thank you. If there are no further questions, we'd like to call it a day. Thanks for coming around for this information session. And